Hey guys, so today we're going to talk about a new subject, a new geometric subject called volume, and we're going to focus in on one particular shape. We're going to look at the volume of rectangular prisms. Okay, and that's a fancy word for boxes. We have rectangular prisms. We see them more often than any other shape in our world. All right, so let's talk about what do I mean by volume. So we talked about area is the number of little squares, perfect squares that are inside of a bigger shape, okay? And so volume is the amount of space. So space now takes on a new type of measurement because it's not just flat, it's three-dimensional, right? It's the amount of space inside a three-dimensional figure. Okay, so I'm going to draw a three-dimensional figure, and literally your age and beyond, if I doodled, this is what I doodled on all my school papers. I still have like a notebook from junior high, isn't that funny? And I have all these doodles on my denim notebook cover. Maybe some of your parents or grandparents know what I'm talking about, okay? And so when we're talking about volume, another way is, again, the number of three-dimensional, perfectly symmetrical little pieces. And they are called cubes. So it's the number of perfect cubes that fit inside a three-dimensional figure. So imagine I have those, you know, we even have them in the room, little cubes. How many of those would actually fit into something that is beyond flat, okay? So when we talk about three dimensions, and we are speaking specifically of a rectangular prism in this particular place, so the three dimensions of the rectangular prism will include two that we're familiar with rectangles, length and width. The third one has two different names. It's either called height or depth. When you think about depth, you're thinking about making that flat object now be something that's three-dimensional, that when you push it against the wall, it's going to stick out. I'm just looking at my wall in my bedroom right now, and I'm looking at the frames of framed pictures I have on my walls. All those frames are rectangular prisms because they jut out from the wall. And you could argue a piece of paper is a rectangular prism, but the depth of that paper is so small that it seems that it goes flush against the wall. So a lot of us will look at that as being an actual area is the only thing we can look at, okay? All right, and then, of course, because we have three dimensions, that's going to change our labeling to one that indicates there's three of the same unit. So unit of measure. So for this three-dimensional shape, you're going to get cubic units. So that's one way to write it. You can write it CU units for cubic, or you could actually units, and the 3 goes on top, but we still read it as cubic units. So again, units are inches, feet, meters, miles, millimeters, so on and so forth. Now we can also talk about liquid volume, and that's going to give us milliliters and liters, okay? All right, let's see. So let's talk about our rectangular prism in particular. Okay, so again, it's a three-dimensional figure, which means I can find its value, where the top, top and I write bottom, isn't that funny? The top and bottom shapes are called bases, and they are congruent. And we talked about congruent in a prior lesson, and congruent means they're the same shape, so they're rectangles, and they're the same size. That means their dimensions match. Okay. All right, so I'm going to go ahead and draw a larger version of my rectangular prism and take my drawings with a grain of salt. And I'm going to use my Superman vision so I can see through. Okay. And so when I talk about the top and bottom base are congruent, I'm actually not revealing the whole story. So let me kind of highlight the top and the bottom. This would be the top. And opposite it would be the bottom. So there's three sets of opposite sides, okay? So top and bottom. These are the ones we're going to call bases, okay? So we have two rectangular bases. Now that's important because we're going to be using information from those bases. And when I think about base, I think of the bottom. We're going to use information from them to help figure out volume, okay? Now, the rest of the rectangles are called sides or faces. And there's four of them. So 4 rectangular sides or faces. Okay, and you could actually call all of these faces if you wanted to. So I'm going to kind of draw an arrow and I'm going to label them. So that right there is going to be the right side. And as I continue going around, right here is going to be the front. And then over here is the left side or the left face. And then I'm going to go this direction to try to get right here. And that's going to be the back. So I'm going to kind of do a little bit of connectors here. The right and the left are going to be congruent. And the front and the back are going to be congruent. Now, all 4 of these rectangular bases, or all 6 of them, excuse me, so the 3 sets of congruent ones, are not necessarily congruent to each other. Now, if it was a cube and all the dimensions were exactly the same, yes, then all 6 of the surfaces would have the same exact dimensions, okay? So, again, bottom line, we've got 6 faces or sides altogether. So even though we called the top and the bottom bases, we could still call them faces or sides, okay? All right, so I'm going to go to my next screen. This is about halfway through that first page, And we're going to now launch into the formula. So what I'm going to do is give you one formula for any prism. So we're only going to study two in this chapter, the rectangular prism and the triangular prism. But you're going to learn about a lot more down the line. But this one formula is the basis. So it's V equals big B times big H. Okay, so let's identify each of those. So the V stands for volume, of course. The big B is going to be the area of the base. So for me, I'm going to be thinking about the bottom. So it's like the unique size. When you do triangular prisms, you realize the triangle is always going to be your base. Okay? And then the big H is height, but it's height of the prism. Now you think about it, we've seen little h's in formulas, like for example, when we're doing area of a parallelogram, we said little b times little h. So that's the two sides that form a right angle, or the two parts. Often with a parallelogram, the height often shows up inside because your parallelogram sides don't have to meet at right angles. Rectangles, they do meet at right angles. And so we have that, or we can also use the same formula, little b, little h, little base of that shape times the height of that shape. Okay? So how does the formula change based on us coming up with a new shape? So if I want to know the volume of a rectangular, let's say a rectangular prism, the only thing that's going to change with this generic formula is what I put in for the area of the base. So for me, I know that the area of a rectangle is length times width. So now I'm just going to multiply length times width times height. Okay, so this is based on the base of the prism. Okay, and again, the big H is going to be separating the prisms from each other. All right, so let's go ahead, and I want to talk about a particular example of when I would think when you're practicing you would use a calculator. Now, I think Alex pretty much allows you a calculator on the more challenging problems anyway, but this would be the instance of when all three dimensions have decimals, just for sake of time. That's when we in class would actually use a calculator. So I'm going to show you what that looks like. So decimal dimensions. So in the event that all three, okay, so if all three dimensions are decimals, you may use a calculator, but show all work. Now you're going to say, how can I show all work if I'm using a calculator? That's exactly what I'm going to demonstrate to you. Okay. Now remember, some of you may recognize, hey, we're doing this online learning, so Ms. Rosner's not checking my work right now, and the reality is you're right, okay? There's some things that are going to be very challenging for us to do. I do things differently with my algebra kids because they have higher stakes right now of what math class they're going to be in is based on how they do on their placement test. They have to take a high school placement test. You guys are maybe going to 7th grade next year, and your teachers are not going to allow you to use calculators. On some things, yes, but on most things, no. So you've now had several months of not needing to show your work, but that is not going to be the way it always will be. Now, often when you have decimals, you will see some directions that will ask you to round to the nearest tenth if necessary. So that means if your problem terminates with 1 digit in the tenths column, then you don't have to round. If you have 2 digits after the decimal point, then yeah, you will need to round, okay? So let me bring in kind of a, maybe like a pizza box. Okay, and you will see 1, oops, 2, 3 numbers. They're not going to give you any more because there's only 3 unique numbers in all rectangular prisms. They just match up in different ways for the different sides, okay, pairing of sides. But with volume, that doesn't really matter. So we start with the formula, volume equals length times width times height. So where I'm going to look for the base is going to be here is the base. Now I'm going to keep coloring him in so you can see where he is. So I'm going to figure out the area of that shape, which is a rectangle. So I'm going to replace the length and the width with its values. So I'm going to get 3.2 times 2.6. And by the way, do not judge the drawing and the numbers. Just trust the numbers. Now the third guy is going to be the dimension that separates the bottom from the top. So it's going to be a vertical line from the bottom to the top. So that's going to be your height. Okay? Now, this is where the calculator gets used for the first time. When I multiply 3.2 by 2.6, the answer I get is 5.44. I still have one more calculation to do. So this is what I mean by showing work. Since our brains can only multiply 2 things at one time together, we're only going to let the calculator do 2 things at one time, and that will also slow down and hopefully eliminate careless errors. So then I get to use the calculator, oops, I didn't do that right, sorry. A second time, and I'm going to multiply 5.44 times 1.7. And when I do that, I get 14 and 144 thousandths. But now I need to follow those directions that said, if necessary, round to the nearest tenth. And because I have 3 digits after the decimal point, it's necessary. So I identify the tenths column and identify the guy to the right. And our rounding rules, remember, are 5 or higher, round up by 1, the guy in the column we're rounding to, and then if the guy to the right is less than 5, then the guy in the column we're rounding to stays the same. So for this problem, we would get 14.1. So, but actually, I've written something incorrectly, because equals means that answer is exact. So actually, our answer is approximate, and we've used this symbol before, which means approximately, about, okay? So when I write out my answer, I say the volume is about, and I use about because it's fewer letters, about 14.1, and here comes your labeling. I've got feet, but since I'm multiplying feet times feet times feet, feet shows up 3 times. So that would be my answer to this problem. Okay, I've got 2 more examples, and then we'll be done for this set of notes. And again, we only have 2 sets of notes for this particular chapter. So now I'm on my second page. So lesson 10.1, a volume of rectangular prisms. So we're going to do 2 types of problems, just like we've done in the past with area. We're going to have one where we're going to find the volume, and the second one's going to be find a missing dimension. So we're going to have a rectangle. So this is our first example. So again, don't trust what it looks like, trust what it says. So 12 centimeters here, 10 centimeters here, 6 centimeters here. And just note too, when you're looking at things from an angle, it may make things look smaller or larger than in real life, okay? So I'm going to identify my 3 key players. I'm going to make 12 from the bottom be my length. I'm going to make 10 centimeters be my width because it's still part of the bottom. And then separating the 2 layers is going to be my height. Okay, so then I'm going to go ahead and just start with my formula. And I always start with writing the formula so that I memorize it. So I get volume is 12 times 10 times 6. And then we're just going to solve it like we would with order of operations. So I'm going to multiply the first 2 and I get 120. And then I have times 6, and then I multiply those. 12 times 6 is 72 with an extra 0. I get 720. So then I would say the volume is 720, and we're going to say cubic centimeters. So here's a different way of writing that, cubic centimeters. Okay? All right, let's do the other one that says find the missing dimension. So they're going to give us that's my make a dimension sound. Draw my figure. And then they're going to tell me what the volume is. Okay? All right. So we start with the formula. Well, first I'm going to identify. So I look at my bottom of the shape, not my bottom. Ha 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 ha. And I have the length is going to be the 6. The width is going to be the 4. And obviously height is going to be h. So when I put in my formula, volume equals length times width times height, the weird piece of information I'm given is I actually know the volume. So 84 is going to go in for V. And then equals, and then we have length is 6 times width is 4 times height, which is going to just stay height. Okay, so we're going to do the math on the right side, and we get 84 equals 24 times h. Now this goes back to our chapter 7 when we're solving equations. So in order to solve this, we're going to divide both sides by 24. Oops. Now 24 doesn't go into 84 evenly. I am going to use my symmetric property, and I get h equals, and then I'm going to start simplifying. Well, I know I can reduce by 4 each of those. So I'm going to start there and see what that gives me. So let's see, 4 goes into 8 twice evenly and into itself once. And 4 goes into 24 6 times. And then I notice, oh yeah, stinky 3 hiding out. So I'm going to divide top and bottom by 3. So 21 divided by 3 is 7, and 6 divided by 3 is 2. So this is where we come into the same problem we had when we were doing measurements before, is that we cannot measure in improper fractions. So we will have to take the 7.2 and convert it to a mixed number. 2 goes into 7 3 times, which is 6, with 1 left over. So I get the height is 3.5 meters. Now you might say, well, why isn't it cubic meters? So let's explore that. So remember, we have volume, and it's cubic meters. And then we're going to have meters times meters, and then we have this we don't know thing. So when I divide meters, I'm canceling out one of them. Okay, so I have this, and then I divide out another one, and so boom, boom, and then that's going to cancel out another one. So that's how I get that the label for my height would just be meters. Okay? All right, guys, have a great day. And oops, if I could get myself back to black, that would be good. And that's all I got for you. All right, we'll see you soon. Bye now.